Okay, so let's talk valence electrons. So in the warm-up, you did the shorthand configuration for each of these elements, and you'll notice that they're all straight out of group 1, lithium, sodium, potassium. This is a sample out of group 1. What I wanted you to look at is how many valence electrons they have. So remember, our valence electrons are the s and p orbital electrons from our highest energy level. So looking at this highest energy level, we have 1 valence electron for lithium, 1 valence electron for sodium, 1 valence electron for potassium. So all 3 of these have 1 valence electron. Now if you think about it, that's going to be true for this entire group all the way down. This is 1s1, this is 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. So everybody in this group 1 is going to have 1 valence electron. Okay? So let's put a big number 1 on the top of group 1 to represent that it has 1 valence electron. If we look at group 2, you'll notice that there's a similar trend, although this time it is 2 valence electrons. Everybody in this group has 2 valence electrons. So above group 2, we're going to put a 2. Okay? Now, what about this group in the middle, the D block? These are commonly known as the transition metals. Okay? And you'll notice something interesting. These are 1A, 2A, and then it goes 3B, 4B, 5B. That's because we sort of treat this group separately from these, what we call the main block elements, because they're a little bit different. But in terms of valence electrons, if this is the D block, do we count the D for valence electrons? No, we don't. It's only S and P. So through this whole section, the number of valence electrons that we're going to have is always going to be 2. Okay? Because we fill the 2 in S, and then we go to the D's, which don't count for valence electrons. So they're only going to have 2. All right? Let's look at group 17, the halogens. So now remember, for S and P, we want to add these 2 together because they're the same, the biggest number of the big. Okay? So we're going to add these together. So 5 plus 2, that's 7 valence electrons. 5 plus 2, 7, 7. So group 17 has 7 valence electrons. So let's put that on here. And then our last special family that we're going to talk about is the noble gases. They have 2 plus 6, which is 8, 2 plus 6, which is 8, 2 plus 6, which is 8. So on our periodic table, we're going to put above group 18 that they have 8 valence electrons. Now, there is one exception. Remember, helium only has 2 electrons total. So helium only has 2. The reason he's over here is because just like everyone else, helium's highest energy level, which is the first energy level, is full. That's why helium belongs over here with the other noble gases. His energy level is full because the first energy level only holds 2 electrons. So now, based on this, we see that over here we start out as 1, 2. Keep it 2 all along. If you think about it, this is this is 2p1. So this would be 1 p orbital plus the 2 from S. So this would be 3. This would be 4. This would be 5. And this would be 6. So you'll actually notice there's a pattern on the periodic table. It goes 1, 2, 3, 4, 5, 6, 7, 8. That pattern of valence electrons is why we have these special families. Okay? All of these elements have similar chemical and physical properties because they all have 1 valence electron. So when they get into a bonding situation, it's that 1 valence electron that participates. Since they all have the same number of valence electrons, they participate in chemical reactions in a very similar way. Same is true with group 2 elements. They are all going to share similar properties because they have 2 valence electrons. So if you remember when we did the Mendeleev activity, he organized everything by atomic weight and then kind of made sure that the properties lined up with their patterns, and he broke them into rows so that all of the special families lined up. We didn't know until much later that the reason that all those special families line up is because of the number of valence electrons. Okay, so this pattern of valence electrons sort of tells us how those elements are going to behave. So in your notes on Canvas, there are some reading passages over each of these special families. Because they're all in the same group, they're going to have similar properties. So what are some properties of the group? You're going to use those reading passages to determine some properties of the group.